First of all, I am here as a customer, so I'm here mostly to share my story, share my point of view, and so we should not be tied to this presentation. This can be a conversation. If you guys have any questions during my presentation, raise your hand. We have not plenty of time, but we have some time for questions, okay? Let me introduce myself first. My name is Rodrigo. I work in Brazil. I started working with RavenDB since 2013. So not too much experience with that, but we got to learn a lot with it. I am software architect manager for RDI. That's the company I work for. But I am also a developer, and I am always going to be a developer. So I have a developer mindset, okay? And I've been working with software development for the past 14 years. The company I work for is called RDI. We create software for restaurants, for quick service restaurants, okay? Let me throw some numbers here, and then I would like to know a little bit about the audience. We are running today on more than 36,000 restaurants, so that's quite a large number of restaurants. And we estimate, we don't have the real numbers for the individual machines, but we estimated that we are running on about 500,000 of individual machines. Okay? And our software process today about a little bit under 50 grand per second in customer payments. So that's quite a large amount of money. I would like to have a little bit of, just 10 seconds would be good enough for me, you know. But, it's kind of massive scale. So that's the title of this presentation, right? RavenDB embedded at massive scales. We probably don't have a lot of hands today, but how many of you use or have used RavenDB embedded for any kind of usage? Oh, it's more than I anticipated. How many of you guys are using that only for testing and unit testing? Okay, so we do have some kind of production usage of RavenDB embedded here. That's good. When you get to this level of scale of deployment and processing, we have a problem. Our problem is that any issue that you have in your software is gonna show up very quickly. So I really like this quote from Gordon Letwin. He's an architect for DOS 4. 1 in a million is next Tuesday. This is really true for us. This is the core. This is the essence of our software. May I grab some water here? Sorry. I forgot to get mine. Thank you. So why is that so true? Well, if you have something that can go wrong 1 in a million times, it will happen next Tuesday, or most probably it will happen sooner for us. So this kind of issues is very important for us, that we need to choose something that is stable, that we can trust, and that we have the right amount of support, right? So before I start talking about how we use RavenDB on this kind of level and how we enhanced our software, I would like to talk a little bit about how we use it to do before RavenDB. So how we use it to persist data on our point of sale. POS, point of sale, that's our core business, our core software, okay? We have other softwares, but I'm gonna focus today on our point of sale platform, okay? So how we use it to do that? Actually, we still do on some legacy modules, okay? Our legacy persistence was not complex at all. We used flat files, literally text files, to store the data. We designed a custom data format for that so we could fine-tune for our needs. And it's based on event sourcing persistence. So that's a very different type of persistence where instead of storing data, you store events, right? So you start from scratch with, like, your memory is empty. and you start storing every single transaction that happens on your system. So every time that you start your application, you need to reboot its in-memory state. It works. In fact, it has worked for the past 15 years. We were able to deal with that. But we know how things are progressing so fast today in this modern world. We need to be competitive. We need to add new features. We need to add new capabilities. So we found some problems with that kind of approach for our persistence layer. First problem, there's absolutely no querying support on this persistence layer because we are just storing events, right? So if now I need to do some kind of search over the data, it means that, OK, during startup, I need to model a data structure that will be populated during the rebuild process at the startup. And it will be populated so I can query this data structure later on, right? That's not how we want to make it faster development, right? So we need to have fast development, so that's quite complex. It's also quite hard or quite complex to store new kind of data on that legacy persistence model because every new record type, we are going to design it. We need to know how to write it. We need to know how to read it, how to parse it, how to deal with that. So creates friction. Every time you need to store data, it's not easy, right? It's doable. We can get along with it, but it's not easy. There's absolutely no standard data format. So you don't have something like JSON or XML that you can visualize the data and look at that and put in a notepad or a Word document and try to understand it, right? Every kind of record on our system, if you don't know the data model for that record, it's almost as if it's encrypted. You can't do anything with that. And of course, it's a custom designed in-house solution, so we don't have management tools. We don't have commercial management tools to handle that data. So the world is evolving. The software needs to evolve. It has been working for the past 15 years like that, but we needed something better. So OK, we decided it's time to choose a database management system. Why we decided to use a database management system after all? Please notice that I'm not saying a relational database management system. Okay? Well, the first thing that led to this decision was we started a full re-architecture of our point of sale platform, right? So that was definitely the right timing to do that. So that's the perfect occasion to do this kind of big architectural decisions. We are definitely not database specialists, and we don't want to be. That's not our core business. We don't know how the hard disk spinning works. We don't know this kind of stuff. We don't want to worry about that kind of issues, right? And of course, we wanted to remove complexity to persist data. So, like I mentioned, it was quite hard to store new information. You need to design a custom record, think about it, know how to write it, how to read it, how to rebuild during the startup. So we wanted to make it better and faster. Then we started the seek for the right DBMS, for the right database management system for us. I can bet that most of you guys here in this room had this kind of seek, right? When you started thinking about, OK, should I go to SQL Server? Should I go to Oracle or whatever? You need to do this kind of seek and proof of concept and tests to make sure that you are going to the right decision, right? How many of you have been doing that for, I don't know, more than a week? More than a month? OK, nobody. So I guess more than a week wins. We did that for 6 months. We did a total of probably 15 full-blown proof of concepts. with a lot of different options because our use case is so different that we were not sure what we're gonna work right for our use case, right? So we started the SIG, and we had some guidelines or some goals we wanted to achieve. First goal was the new architecture. Oh, go ahead.
I was going to say something, ask you about your SIG process. How did you not have somebody kind of right off the bat decide that it's going to be, XYZ database? Because I think that's probably why most people haven't spent more than a week, because somebody has already decided what it's going to be before the process starts.
The main reason is because I was in charge for that. So yes, that was probably the ideal scenario for anybody making this kind of SIG, right? So I didn't have a top-down order. Hey, you're gonna seek for the right database, but it's already, I know this is the right one, No, this didn't happen to me, so I had the autonomy to do all the tests that were necessary. And I probably talked millions of times with Oren and his team during this process, and our lawyers also didn't make him much happy, but in the end, it worked out. So the first goal is our new architecture, the software architecture of the point of sale is based on the plugins concept and a plugin architecture, kind of microservices. So we wanted to be able for each plugin to have its own isolated database. This concept of service-oriented architecture or something that you're not going to access data, you're only going to access APIs. And that API is going to hide the data, the internal data format. We needed to be able to do that. It's extremely important for us that it needed to be zero administration. You saw on my second slide the numbers. So we are running on about 500,000 machines, 36,000 restaurants. So I cannot have a DBA for each restaurant. I cannot have someone going on the restaurant and installing SQL Server Enterprise and doing the manual configuration of everything. The software needs to be able to handle everything from scratch, right? So we definitely needed something that supported embedded operation mode. We wanted to have easy schema upgrades, no matter if we end up choosing a relational, for example, we needed to have a solution for that. So of course, if the software itself, if the database itself supported it, it would be even better. And we needed to have transparent replication because one of the goals of the new architecture was that, remember I said the plugins? One of the goals of the architecture was that you could have failover for the plugins very easily. So if with transparent replication, all we need to do is, okay, we have two copies of the plugin. One is dormant, one is sleeping, but the data is flowing transparently from one to the other. If one dies, I can just start the other one, and there we go. It's like magic, and it works. But this is like business goals, but we also wanted to have the last one, which was support for unit tests. We had zero test automation with our old persistence layer because it was so hard to fake it or to mock it or somehow unit test it, right? So this was very important, not for the core business, but for us as developers. And again, I am a developer, so I really put this as major decision points during this SIG, right? So I mentioned this took like 6 months. And in the end, I'm not going through all the details about all the different options, but in the end, we end up choosing RavenDB. Why that? Well, also, it would probably not fit here in the presentation, all the individual analysis and tests that we did, so I wanted to highlight just a couple of them here. First one, we are running in embedded mode, so the fact that RavenDB is .NET based and C# only contributed to this decision because it doesn't really matter if you're a client server, what's the technology on the server. But for embedded operation, it's quite important that it matches and fits perfectly with your software, right? So our software is .NET, so it really made sense for us. It supported the embedded operation mode, so we could do the kind of zero administration. Like the restaurant operators, they don't need to worry about having a database. They just need to worry about having our software, right? They install our software, everything is under the hoods, everything is being managed by us. They don't need to worry about anything. Oh, this is so important for us. So we have the support for in-memory modes during unit tests. So we're finally able to do complete, very good unit testing without having to mock everything. It's also multi-tenant. Even though we are using it embedded, we use the HTTP protocol to have the support for multi-tenant. So what we end up doing is that every single plugin, every individual plugin instance is actually a database inside Raven. And Raven can handle a large number of, up to a certain limit, of course, but it can handle a large number of databases very seamlessly, which is awesome. And it contained a very good set of options for transparent replication, which allowed us to have this goal of transparent failover for our plugins. Of course, performance, et cetera, were also important facts, but here are the most important ones feature-wise for us, right? Okay, then we did this very short six-month SIG, and we evaluated everything. We decided, okay, RavenDB is the way to go, and we started using that. Let's start with the good things. What RavenDB brought to our software? What were the benefits of that? First one, and I love this one, is we have very good unit tests now. We have a target on our system that it must have a minimum of 95% of code coverage in unit test code coverage, not counting all external system automation tests that we have. Also, with the in-memory operation mode, we can start up our software not in unit tests, but in real environments, in the real hardware, for example, but with the in-memory flag, so we can extract the system very quickly and do some testing on top of that, automated test on top of that very quickly without worrying about the I/O, without worrying about cleaning up everything afterwards. Also, now finally, we have advanced statistics about the data persistence because, like I mentioned, our previous or legacy persistence layer was custom designed, custom built. We didn't know what was going on in there. We only had one metric, which was the file size of the text file. That was the only metric. We didn't know which module was taking up more space. We didn't know which module was writing more. So now we have both system-wide and per plugin advanced statistics. The transparent replication of RavenDB also brought us a lot of different options, and we are really making use of that. We are making use of transparent replication for hot failover. If you imagine a quick service restaurant, you have some modules that you don't care too much if it's down. For example, if one register goes down, you just shut it down and start using another one, right? But for some of the modules, they are pretty important. For example, the modules that does all the routing of orders in the kitchen for your production, right? For producing your order. We cannot afford to have this module going down, even in case of hardware failure, right? If the hardware goes down, we need to be able to switch to another failover server. In the legacy persistence solution, we did that, but every time we needed to do some kind of failover on a new module, it would probably be about 3 or 5 months of development to achieve that. Now with RavenDB, we are finally able to have this transparent replication at the plugin level. So we just need to choose, okay, I want to have a failover of this plugin. That's it. It's just a configuration now rather than a development. So this is one use case for transparent replication. Another one is data distribution. Some of the modules need to synchronize data along the whole restaurant, right? One good example of that is biometrics. We have a solution for fingerprint scanning where you're gonna enroll the cashier operator or the manager, etc. You're gonna enroll his fingerprint and say, okay, I am Rodrigo, that's my finger. And you need to synchronize that among all the nodes because if you enroll and register, you can go in another one and log in using your fingerprint. We just synchronize this. This is a single plugin, so we just synchronize this kind of data throughout all the plugins of the same type inside the restaurant. So we didn't have to write a single line of code to synchronize it. We just configured RavenDB to do the synchronization on the fly and transfer it to us. So if you modify in one node, all the other nodes are automatically modified at near real time. And we are also leveraging that for near real-time backup. So if we have something catastrophic going on, even though we might not have the hot failover, the data is there, the data is safe if we need to get to the data, right? And we are also leveraging the transparent encryption bundle. So some of the information that we store might be a little sensitive, credit card information, even the biometrics information. So we are trying to use the transparent encryption of RavenDB to store that in a safe way and encrypt that data while it's at rest. So like I mentioned, the SIG started in 2013. So we've been really using, like in mass production, RavenDB for the past year or so. So we don't have a huge amount of time of experience with that, but it already brought us some challenge because of the scale that we are running, right? So let's talk a little bit about some of the challenges we faced. Okay. First challenge we faced was memory constraints. Our software is not the typical line of business software that you find on running on a data center with those powerful servers running on AWS or Azure or whatever. We run on this kind of hardware here. We run on specialized and typically very old hardware. Why that? Because the restaurant operators are not going to upgrade their hardware unless it's completely broken, not turning on anymore, right? So we need to support, unfortunately, we need to support quite old hardware, sometimes like 10 years old hardware, which also means that there is very little processing power, there is very little memory available, and this creates a lot of restrictions on that.
What's the typical memory available to you on such a machine?
We have to operate with minimum of 1 gig, and that's for everything that is running on the register, and including Windows, which is, you all know, takes a good part of it. Yes, we need to support Windows XP embedded. It's still, yes, unfortunately, we have bought support for Windows XP embedded from Microsoft until December 2018. So we still have to support it for quite a while. Memory constraints. When we started using RavenDB under those serial constraints, we end up, how can I say, hitting some barriers that we didn't find before in our early testing. So we had to bother RavenDB support team for quite a while, and they were very helpful. Probably some of you guys did help us doing remote desktop sessions to this kind of hardware here, trying to figure out what is going on over there. So we had to use our support with RavenDB to fine-tune its memory usage for this kind of scenario and for this kind of constraints. And we learned that under this kind of constraints, caching can be quite evil. Caching is awesome. Caching is good when you have a lot of memory, but under this kind of constraints, caching can actually hit your performance really, really hard. So in the end, we actually modified RavenDB for that need to be able to completely disable caching, because it made no sense if you have 1 gig of memory available to have some caching. And then we had to do, of course, instead of doing I/O all the time, we did some caching at the application side. Unfortunately, that's the only way we found to operate under these constraints. That's certainly not a problem if we're talking about a web app or a website, because you're going to run on at least on something better than this. I hope. I really hope you do. So that was the first challenge, and it was not a small one, because it took, if I'm not mistaken, about 2 months of very specialized investigation, fine-tuning, and even modifying RavenDB source code to reach to an acceptable level. Challenge number 2 is related not to RavenDB, but to Ascent. And first of all, we are still using Ascent because we are still using RavenDB 5. Why we are still running on 2.5? First, I mentioned before that our software must support Windows XP embedded, and it must run on that until December 2018. That means that we don't have .NET 4.5 or 4.6. We only have .NET 4.0, and we cannot upgrade to Raven 3 or 3.5. Also, we are running on 32-bit machines, so 4.0 was unfortunately not an option for us, and will not be for some time. So in order to keep Ascent, we had to learn how to deal with Ascent correctly, right? There's one fact about Ascent and RDI. For our user scenarios, don't understand me well. That's not that it's a bad solution. It's just probably not the right solution for our use case. Okay. Why that? Well, we had some very funny behavior from Ascent during unclean shutdowns. From our experience on that kind of crappy hardware over there, you can have all sorts of completely undetermined results from unclean shutdowns. We traced that to a variety of factors. Faulty hardware, one of them, hardware that doesn't obey low-level stuff such as really sync to disk when it should, and well, all kinds of stuff. But the end result is when you are running on such a large number of machines, on a large number of crappy machines, on a large number of different locations that don't have no breaks, you have a lot of power losses, you have a lot of manual intervention, we have a lot of people going there and just killing the application because it needs to restart. So it gave us a lot of experience on how to handle unclean shutdowns and Ascent. It's not funny at all. Because of all those possible results that you have from unclean shutdowns, we just couldn't find that during our early testing, during our system testing, because really depends on the hardware, if the hardware is obeying the low-level stuff or not, if the hardware is faulty or not. So it's very hard to find this kind of errors or problems during system testing. Right? We eventually still face some full database losses with Ascent, most probably related to crappy hardware and hardware faults. But it's not fun when you have that, because you would expect from a tool, especially from Microsoft, that you would be able to recover part of the data when that happens. Not possible at all. Sometimes full database losses with vSANT specifically. And remember, you're not blaming vSANT only, but of course it's a combination of vSANT and traffic migration. Another factor that we don't like vSANT is that copying data between OS versions is awful. And we have a lot of different OS versions, unfortunately. We Windows XP embedded, but that's not the case. Variety of different OS versions, Windows versions running on the restaurants. So if you need to grab data from a restaurant and pull back to our office to investigate it, and sometimes we have like 60 gigabytes database, it's gonna take a while to migrate all that, and well, and that's vSANT under the hoods doing this migration. It takes a while, so we don't like this, that it's tied to the operating system, the internal data format. And recovering from those undesired unclean shutdowns require using external executable. It's usually included on Windows, of course, the vSANT-U2 executable. But for the funny thing about Windows XP embedded, or any embedded version of Windows, is that it allows you to modify it any way you want. And some of our customers, they just removed the two because they thought it was not usable, right? So we had to learn how to deal with this kind of situation. Let's talk a little bit about vSANT-U2. Another fact is that we also don't like it. We don't like vSANT-U2 because, first of all, we had all sorts of different issues when we went to a large number of restaurants. On some of the restaurants, it was simply not there. On some of the restaurants, it was there, but it was the wrong version. On some of the restaurants, it was there, it was the right version, but then the vSANT DLL was the wrong version. So it had to deal with all this kind of weird environment issues, and our software literally ships embedded a lot of different versions of vSANT DLL and vSANT-U2 and tries to find during startup, okay, what's the right version to use on this OS, and try to fix the OS if it's necessary. And another funny fact is that some of the commands that we need to use to recover the database on unclean shutdowns is that it may be a little bit different between OS versions. So we have something on some logic on our code to change the command that is being used based on the OS version. And remember, I said we need to have zero maintenance. We cannot afford to have like a DBA going to the restaurant and, okay, this database is corrupted, let's issue this command and fix it. Okay, no, the software needs to handle all that. So we needed to automate all this recovery process up to a level that I didn't like it that much, but it was necessary. And we have almost 500 lines of code just to start up RavenDB in the correct way. Not because of RavenDB, but because of vSANT. So you can imagine how excited we were when Oren announced that they were working on Voron. Right? So unfortunately, we cannot use it yet, but I'll talk a little bit about that. But, well, the final message for those issues that we have is, okay, we were able to work around that, and we are also working with voting and other decisions for the future. But everything is always painful, right, in the software world. I really like this quote from Winston. Success is stumbling from failure to failure with no loss of enthusiasm. And that's what we did. We didn't like give up, okay, vSANT, we don't like vSANT, let's throw RavenDB away. No, instead of doing that, we're thinking about the future, right? Thinking about the future, we had to think, okay, unfortunately, we are still tied to Windows XP embedded, .NET Core O, and this kind of stuff, but we know that this is not going to be forever. So let's think about that. Our future, we are working with hibernating rhinos to improve Voron for our use case. We had hibernating rhinos going to our office in Brazil, visiting us there, and grabbing feedback directly from our developers and literally hear them crying and complaining about the things they didn't like. Possibly working on support for 32 bits on Voron for the Raven 4.0, and better reliability on unclean shutdowns on Voron, of course. We cannot modify ECent. I don't think Microsoft has open sourced it yet. So this means that we may jump straight from Raven 2.5 to Raven 4.0 because of those things and those enhancements that we are working on. And of course, by doing that, we are also going to core CLR, which hopefully will go RTM real soon. And our long-term target is to have around 250,000 individual machines or individual point-of-sale nodes running with RavenDB embedded for the future. We don't, of course, I would like to share the current numbers for RavenDB specifically here, but it's so hard to get these numbers from so large number of restaurants. I couldn't find a good number to bring, but this is the long-term target that we have. So in the end, we were able to find the best solution for us, work around the problems, and make useful of embedded operation mode of RavenDB. It's sometimes forgotten that it's there and it's useful. Okay, guys, that's what I wanted to share with you. This is more like my experience as a customer of RavenDB on how we use it. Thank you.